Hey folks, welcome to Answer Everywhere. We're taking a look at the .NET runtime. This is a show where we look at some source code every week. We just explore around, poke around, try to simulate what it would be like to be a developer or contributor to the project. And that's how it is. So this is a request from botyeeter. He wanted to look at a portion of the .NET runtime. .NET is, of course, Microsoft's write once, run anywhere sort of thing. I've never personally programmed in it, and I suspect that some of this stuff will be written in C#. And we'll see what we see. In particular, he was interested in the core CLR folder, which is what? I used to know a second ago, but now my brain has been cleared. So I think of .NET as basically a response to Java. Although I can't, every time I've looked at a .NET talk or written material on it, it never mentions Java. But I think that's what it is. Yo, welcome botyeeter. I'm so glad you could make it. For those of you who are not watching live, I got a late start today because of a morning, not disaster, but hullabaloo, perhaps. Okay, so this is I guess the CLR is the runtime for .NET Core, and I think .NET Core is the successor to what used to be called .NET Framework. And botyeater, if you happen to know, and that's incorrect, let me know. And I think the idea was to rewrite it because .NET had been around for a long time. And it's probably going to look a lot like the JVM. We have a garbage collector, a just-in-time compiler, or JIT, and also primitive data types, and low-level classes. Since it used to be its own repo, my guess is that it's pretty big. So where to even start? In fact, it's so big that when I cloned this whole repo, it took about 400 years. All right, so definitely we should look at the interpreter. I'm going to guess interop is either interoperability. Whoa. First of all, there I am. Is either interoperability with between machines, like Windows and Linux, or I think more likely, maybe interop with the legacy .NET framework. JIT is going to be just-in-time compilation. MD is almost certainly some sort of markdown support. Minipal, I don't know what Minipal is going to be. Native AOT, that should be ahead of time compilation for native. Native in this context might just be mobile phones. So let's see if we can see anything that tells us otherwise. Limitation, compiling applications, debugging applications, troubleshooting. Android Bionic. So I'm guessing that's enough confirmation for me to think that that's probably what they're targeting. PAL is platform abstraction. Minipal, no idea. Okay. Minipal is probably some version of the platform abstraction, I would guess. We can look at the platform abstraction, and I would guess that runtime is probably something we want to see. And then VM should be the virtual machine or core parts of it. And then we have some CMake files, some props, probably properties. I don't know what that is. Some hint file, and runtime proj. Proj might be like a VS Code project, I guess. Property group. Some Microsoft XML thing. XML is still alive and well. You may not know it, but it still lives on. cpp.hint. What is this thing? This file is used solely to aid VS. The VS Code thing. But now that I'm trying to remember what VS stands for, I don't know. Microsoft's editor. While editing, it is not used as part of any build. Okay, so this is some hint file. It looks similar to tags, but is not tags. It's got some macros and stuff. And maybe it's just telling the IntelliSense where to how to expand macros. Visual Studio is what it's called. Thanks, HXUU. I appreciate it. HXUU says they love what I do on my channel. I really appreciate that. It's been kind of a hard day, so stuff like that, it makes the day a lot better. You've shared your channel with many of your friends. That's very kind of you. Thank you. Okay, so with that, I kind of feel like, so this was botyeeter's request, and if I'm assuming botyeeter is a dude. If not, let me know. I called him he. I hope that's okay. If that's not, please let me know. Pronouns and all of that stuff. I'm going to start at runtime, I think. Or should I start at VM? I don't know. It looks like runtime is maybe going to be difficult. So in runtime, in the runtime folder, and remember CoreCLR is the name of like the whole runtime thingy. But it has its own runtime folder, and this is some thing that has chips in it. Like i386, AMD 64. You're a dude. Okay. All right, great. Okay, so let's look at, I guess, AMD 64, just because that's what I'm more familiar with. And we have very little here. Some assembly for stub dispatch. I'm guessing stub is like a, maybe like a function stub, like a thing that has a skeleton but not an implementation, and a write barrier. In fact, we have multiple write barriers with an S, and I don't know what the .s file is, but this has AMD macros shared, Intel syntax, no prefix. So this looks like it's maybe, yeah, what's the word? Assembly. Oh no, yeah, we're not gonna look at the assembly. I'm going to wager money that this is all assembly. In fact, let's look at RISC-64. Okay, great. So we can ignore the runtime directory. Here's the VM. I'll move PAL to the end. And maybe the interpreter in the middle here. Okay, and then in the VM, we have, again, some, I said chips, but really they're architectures. We also have an eventing folder, I assume for some sort of event processing stuff, WebAssembly, whatever WOX is, WKS. And then we have some actual real-life CPP files and headers. These are the write barriers used by the garbage collection. That makes sense. Okay, and we have assembly, including assembly.hpp and assembly.cpp and assembly binder. I'm going to guess that this is just setting up the, let's see, what do we even have to do? Like, what are the requirements here? So you've got some virtual machine, and it's going to take a higher level language like C#, or in the back of my mind, I'm really thinking Java because I know Java a little bit better. And you're going to take the C# and compile it down to some representation, like an intermediate language. And if you were a full-on compiler like Clang or GCC, you would then process that intermediate representation into something that can run on the bare metal. The VM doesn't want to do that. The VM wants to create some sort of intermediate language. I'm pretty sure that's what they call it. In fact, it's like core, I think core intermediate language, CIL, was maybe the previous one, and I forget what this one is called. But then they're going to take that and compile it just in time, which I guess means they're going to emit assembly, something that could run on the bare metal. And so maybe we should look at that kind of from that point of view. So maybe we should start with the interpreter, and then look at the JIT, and then look at the whatever that thing was that had the assembly stuff, the VM. Unless there's a really good file that looks like it's describing the VM that we can check out. CLRX, I'm guessing, no, never mind. We've got things like stack traces. Okay, yeah, so I'll try that. I'll look at the interpreter first. All right, here's interpreter. We don't have as many folders. That's good. I guess I will give it its own frame just because we're going to open a bunch of tabs here. Int ops. So these are presumably interpreter ops. We have a stack map. So I don't know what that's going to be. Something about stacks, maybe mapping it maps things into stacks. Maybe it maps stacks into things, or maybe it's a stack implemented by a map or something. I don't know what EE-interp is. We have some data structures, some compiler options. I guess we don't care about the options, but we'll look at the compiler. And we have some Unix exports, which is a .source file. I don't really know what that is. But that's, I guess, for supporting Unix. So let's look at these. I need some water. Okay. So int ops might not be interesting. We have interp op no args. So we have some enum. This is like the arity, I guess, of the arguments. Maybe these are just the arguments of the low-level functions, but you can take no argument. I guess you can take an int or a long int. Or maybe rather these are the operands of the virtual machine or something. Whatever they are, we have int, a long, float, double, and then you can either, I don't know if this is functionality or operations again, but it's either maybe like a function that takes 2 ints or 3 ints, or maybe it's an operand that consists of that many integers. And then we also have branch, switch, method handle, and class handle. Okay, so this is looking a little bit like what we would see in a machine. So I'm going to guess that that's what these things are, but that remains to be seen. This, instead of an array of pointers, to optimize away a pointer and relocation per string. Whatever that is. So I guess they have some array. That's xturn const. And opcodes. Okay, so these are I do believe these are opcodes. That's my new position, as opposed to telling you about the functions. And we have some, what? This is like a Boolean function. It says interop is emit new. Oh no, no op. And it's going to take an opcode. And we're going to take that opcode and do this bitwise stuff. And we're going to this is what, like shift equal, and we're going to take the no op enum thing, I think, or whatever it is. It's essentially some like list of bits, and we're going to bitwise AND it with the opcode, and we're going to check whether that's equal to int op move source off. I don't know why that. I was not expecting something called move source off. I have no idea what that's doing there, but at least kind of conceptually taking the opcode, anding it with the no op is the sort of usual thing that you would do when you're using like bit style flags, like you do with opcodes, and so on. We have this I4 little endian. I don't know what I4 is. Maybe integer 4-bit integer for something, and maybe U is unsigned. If we have, so get I4 little endian is we're going to call get U4 little endian on the pointer and cast it as an int32. Okay, so I think that this is just a 32-bit int, and we are just getting the bigger version and casting it down. The JIT is for the brave. That's all I'll say for now. Is this like a say the no up? Yeah. So No ops are you so no a no op is an operation that does nothing. So they're used in various things. For example, in like in a chip that has like pipelining, you might need to just kind of pad out some part of the instructions so that they fit in the right order. And so it's just an instruction that says do no work for this cycle or whatever. Okay, so this is just some stuff for dealing with opcodes. I don't feel like I understand what exactly the opcodes are or how to think about them, but at least we know what that thing is. Here's interpreter stack map slot. And we've got it's a struct that has some offset bytes and some flags. And we have a class. Okay, so this is some C++. And we've got a function that's going to populate the stack map. And it's going to take some core JIT info. I assume I means maybe interface. I don't know what COR stands for. Maybe core as in like the core. And then we've got core info class handle. So we're going to pass it some JIT stuff and some handle of a class. And we're going to populate the stack map with that. And what is that going to do? I don't know. But we have this interpreter stack map, which has a core JIT info and a class handle. And we set the slot count to 0. And the slots, I guess it starts as maybe a null pointer. And then we've got this populate function. Let's see what this function actually does. So this is H as opposed to HH. So I'm wondering if this is actually just straight C. How about CC? Weren't the other headers double H'd? No, they were not. Never mind. Forget I said that, which didn't even make sense. But this is also not a thing that exists. So what is this stack map? Where's the implementation? I don't know what I did wrong, but there is a stack map.cpp. And we've got this SIMD hash. So this somehow is using SIMD and doing something. Assert abort, assert fail, blah, blah, blah. And then this SIMD hash pointer type, I guess it's a pointer to a pointer. And then we're also taking a pointer of that. Is that like triple pointered? And there's some stack map lookup. And we can get the interpreter stack map, but where's the populate? That's what I wanted. We're going to look at the JIT info and get the class size of the class handle. So the JIT should be some sort of output of the just-in-time compiler. So we're looking up the class handle in some structure. And that's going to give us the size, presumably the size of the class. And then get class layout assumes it's given a buffer of exactly this size. So we're going to compute, I guess, the buffer size. And then call alloc. I forget what alloc A is actually doing, but let's look it up. I redirected, right? Okay, so that's not telling me what I want to know. What are the other ones? Like alloc X? There's a bunch of allocs, right? Alloc is not a standard C library function. Some older compilers and libraries contain an alloc.h library. What is up, Stack Overflow? Every time I click a Stack Overflow link, I'm now being told to prove I'm a human. For every single link. Stop this. Alloc allocates memory within the current function stack frame. Memory allocated using alloc will be removed from the stack when the current function returns. Okay. Situations where alloc is appropriate are rare. In almost all situations, you should use malloc. And then malloc allocates on the heap. Thank you. Thank you, botyeeter. You told me what it was. I don't know how long ago you sent that message, but thank you. Okay, so we're allocating on the stack here. Why? I guess because we don't need it after the function ends, and then we have some malloc on the heap here, and we're allocating a slot again. I don't know what a slot is, and then we're iterating over something for the number of GC pointers. Okay, this is garbage collection. I should have recognized that here. So we're going to get some GC pointers, and depending on, I guess, the type of the GC pointer, somehow GC pointers have some sort of enum, like type GC ref, by ref, other, none. I'm assuming ref is a reference. I don't know what a by ref is, but we depending on the type, we might set some flags, and then we're going to compute this offset by doing what? We're taking the size of a void star and multiplying it by I. So that's just basically incrementing a standard size independent of architecture by I think. And then we just have this like array thing, and each pointer thingy that it contains is going to, I guess, point to this little pair of the slot offset and the flags. So this is, I guess, some data structure that lets you look up in the it lets you look up the slot offset and also stuff like about the garbage collection. But so how is this different? So slot offset is basically a function of the number of pointers. And then what is slot count? It's somewhere. I guess it's maybe held by the stack map itself. But I don't know how so we're going to index by the slot count. I'm not sure how we go from like the size to what count we're supposed to look up, but I don't know. It's some information about stuff, about stack, I guess. I don't know. We're going to move along. It's the ref type name. It's a managed reference. So kind of like a reference to a reference. Is that what by ref is? That would make sense. They're like a by, wait, where did it go? By. I was thinking BI double reference would make sense, but I believe that a managed reference. Okay, and then here's the einterp. And I don't know what the E stands for, but we have the compile method, which is going to take the JIT info and some core info method info, and some flags, and the native entry and the native size of code are the outputs. Oh, thank you, Microsoft. We have seen, I think, many C repos without parameters. And I think this is the very first one we've ever seen that documents in an extremely clear way which parameters are in parameters and which parameters are out parameters. That's I appreciate that. I type name are indeed interfaces. Thank you, botyeeter. And then we can shut down work and get version identifier and set target OS. So I guess we should look at compile method. I'm going to guess it's not so satisfying. It'll probably call something else. Oh, I typed CC, but what did they use? They use CPP maybe? Okay, that's what I had done wrong before. Okay, so let's see if we can find compile method. All right, so we've got this bool do interpret thing, whatever that is. And if the G interpret module is non-null, then we're going to look at the method info, which we got here, and look at its scope and check if it's equal to the interp module. In which case we will say that it's true. We should interp. So somehow, I don't know what we'll see what do interp does, but maybe that means instead of compiling, like don't compile, just only interpret. We'll find out. Okay, and if we're done here, then we're going to take the compound. What is compound? Compound is the JIT info. And we're going to get the method name from metadata, passing in the method info here. So somehow the method info gives us some sort of information about the function. And we're going to get the method name based on that. But using a method provided by comp HND. And I don't know why that is. Maybe this metadata is like architecture agnostic, but git method name is somehow architecture dependent. I don't know. And if the target is WASM, then we're going to interpret everything, which lends credence to my theory that do interpret was kind of like suppressing compilation. And then otherwise, if we're not WASM, then we've got a to-do here. Let me read the function before I read the to-do. We're going to get some new, I guess, interpret config and create a variable method to interpret and set it to the config, or maybe the config, maybe this doesn't create a new config. Maybe the interp config.interpreter like essentially gives you back a pointer or some sort of handle to the whatever interpreter is running. And then we'll set do interpret to this. We're looking at the method name and comparing it and so on and so forth to see if we should interpret this. Replace this by something like the JIT does to support multiple methods. Okay. Otherwise, if we do interpret, then we setginterp module to the method info scope. And if we don't interpret, we return core JIT skipped. So in fact, my theory was exactly wrong. It's the inverse of my theory is true. So interpret, I guess, means that we are going to compile it. And the not do interpret means we're going to skip the just-in-time compilation, it looks like. And then we get a compiler passing so the compiler depends on the comp HND and the method info, which is a little bit surprising, but that's some interp compiler. And then we're going to call compile method. Seems like you could just have the compile method function take these things, but who knows? And that gives us a P method. P stands for what? Maybe interp. But this should be a lower level thing now. And now we're dealing with int32s. And we're going to get the IR code intermediate, maybe, code size. And then we're going to call compiler get code on the IR code size. So maybe this compile method doesn't return the compiled method. Maybe it just returns like some like name or handle for it. And then get code actually populates the code or something along those lines. Fix me, this shouldn't be here. Okay. And then we're going to set some method attributes and then get the size of code by computing some stuff, which I guess is different from the IR code size. And some stuff about unwind info, maybe like stack unwinding sort of stuff. And we're going to allocate, so the hot code size is going to be size of code. Cold code size is 0. And we're going to allocate some memory, which makes sense. We store first the interrupt pointer, blah, 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 as the code header, followed by the actual code. The interrupt method pointer rather. Okay, so we're gonna store both the code, which obviously we need to store somewhere, and also the interp method pointer, which is going to be just like a header to help us deal with the code. And then we've got this hot code block RW. Read write. We're going to set it to p method and store this other stuff. Probably just doing what this comment says. And then we're going to get the hot code block, set it to the entry address variable, set native size of code to size of code, and then we're going to call compiler build gc info. So now that we have alloced the memory, I guess, we're going to build the garbage collection information, passing in the p method, and then we're going to return coregit OK. I don't know. Okay, so there is other stuff like coregit skipped. Okay, so I don't know if I totally followed all of that, but all of the lines seem like reasonable things to do if you are if you're building a JIT. And so botyeeter is asking, so interpreting is just JIT compilation under the hood? Yes. Yeah. Wait, I guess does that sound right? My life was a lie. I feel like what it should. So this is EE interp. I don't know what EE is, but my guess is that the stuff that is I think that when core CLR is looking at code and deciding whether to interpret it, it's looking at the intermediate language code. So I don't think this is like interpreting C#. I think this is, execution engine. Thank you. I think that this is interpreting let's see if we can look it up. I think it's interpreting the intermediate language. Manage code. There's MSIL. Is it just called whoa. Is it MSIL? Is that the right thing? I'll call it MSIL for now until maybe botyeeter corrects me. Or maybe Google will tell me the answer with its AI. Common intermediate language was, okay, so now we know that this is. Whoa. Okay, so I guess CIL is the new thing. Do we have a reference to .NET Core? I don't know. Okay, so I'm going to guess it's called CIL. So I don't think your life is a lie, because I assume that what you're saying is that interpreting is JIT compilation under the hood. I assume that you're thinking of interpreting like the C# language, the language that you write. But I think that this is a layer deeper in that it's interpreting the CIL, although I'm not positive. For fun, we can try to look at this compiler function in this file. I guess you can't find the definition, but you can probably find interp compiler. Go here. But we can just find it in search. So here's interpreter compiler. Is that where it was? Where was I, first of all? Step 1. No, it was an EE interp. Okay. Just for my own sanity. Okay, so here's compiler.h. This is just the header. And this is really just going to tell us the function signature, honestly, although there is documentation. This represents a mapping from indexes to pointer-sized data. During compilation, an instruction can request an index for some data, like a method description pointer, that it will then embed in the instruction stream. The data item table will be referenced from the interpreter code header during execution. Fix me. During compilation, this should be a hash table for fast lookup of duplicates. Should it though? This is definitely the sort of stuff where like you should try a hash table. Maybe that a hash table is too big. Sometimes you just want like a list or an array. I don't know how big this code stuff is. We've got generate code, which takes in a core info method info and returns an int. Why? I don't know. And we've got patch init locals. So let's head over to the, here. Let's head over to the CPP file. This seems pretty fundamental. We've got some stacks, whatever these stack types are. We've got I1, U1, maybe int unsigned. I don't know what R is. VT. I have no idea. By ref. This is maybe the by ref thing that botyeeter was talking about. Get interp type from stack type. I don't know. So somehow, I guess you pass in the stack type as an index. Is that right? No. I don't know. Somehow this is going to map stack types to interp types. I don't know what an interp type is, but it's a thing. And here's strings that looks very similar to the to this stuff, except we have an F here where we don't have an F here. Why? I don't know. Maybe float. And so on. We've got allocator, but really what I came for was the compiler, the compile function. Let's see if we can. Whoa. Is that lowercase c? We have compile method. Maybe plain old data. Yeah, I don't know. This is C++, so it's not really unclear what the type of the thing is. I'm just not sure, like what the design really of the of some of this stuff is. So the compile method, which is where I think we are, is going to I'll ignore the debug stuff. So it's going to create some IL vars. I'm guessing that's the intermediate language variables. It takes no arguments. I don't know how it knows what vars to create. And we're going to call generate code on the M method info. And then we're going to allocate some offsets. We're going to patch init locals passing in the method info, and then we're going to emit code. So these are all things that don't take any arguments. This is not the style that I am used to. This may be Microsoft style as opposed to Google style. I mean, it's very clean and it looks like a recipe, right? Create IL vars, generate code, and there's no arguments to kind of mess up the appearance of being just a recipe. But the cost of that is, like, I have no idea where create IL vars gets stuff from. It's presumably going to look some stuff up somewhere. So here's the IL vars method. Yeah, so we saw a few minutes ago when we created the compiler, we were passing in, I think, method info or some other stuff. I think it had two arguments. I thought it was weird that the compiler depended on facts about the code. And I guess that this is why they did that, because they, for some reason, want these these functions that take no arguments. And the data they need, they're going to get from the M method info stuff that you passed into the constructor. Is there a reason to do that? I guess there's a reason to do that, maybe from efficiency. Perhaps one consideration is that this compilation process had, let's say, 4 steps, somewhere along that line. And if you were to pass the arguments in to each one, there would be potentially more copying or moving. And that would upset the performance gods, because this is something that presumably runs all the time and has to be blazing hot. So blazing fast, maybe. It's hot code, so it has to run fast. And so I guess that might be one reason why they pass in the method info once, and then everything has access to it from what's the word? Just from the class level stuff. Although, I don't know. Is that something compilers can optimize? I have no idea. At any rate, so we get the method info, building the runtime locally. As in compiling it? The compilers are per method. Yeah, they are per method rather than per process. Instance would hurt more. I'm not sure. I don't know. I'm hoping that they're this way because Microsoft really knows what they're doing and they knew that this was faster, or they benchmarked it. I'm going to guess they did. I think Microsoft is very competent as engineers. I haven't used their products in a while. Some of the products look poorly designed and aggravating to me, but that's not necessarily because their engineers are not top shelf. I think they have top shelf engineers. I would bet that you can just take it and compile it, especially in VS Code on Windows. It should just be CMake, and you may have to download some dependencies. But I would bet it just compiles on like a major platform on Windows. It should. I know it runs on Linux. Maybe it doesn't just compile. I don't know. I've never tried it. And if I try it live now, I think this whole stream will crash to a halt. But I mean, we can look at. I'll look it up. I'll look at the compilation instructions. It should just be CMake, which is, I think, pretty good. What do you think they call it? Build? Building? We have build.command. We do have a build script that's like some bash stuff. So maybe it may not build. First of all, their Azure pipelines have failed. I hope that's like not the official ones. Maybe that's like pipelines built from pull requests or something. So when something doesn't build once and it's got a complicated build system, I just look at their pipeline and build it in a container somewhere. Dependabot, workflows, prompts, policies. I don't know, workflows? Maybe this is too hard. Somewhere. If you know the pipeline format, there's enough pipeline stuff here that I don't want to like click through all this stuff. But I'm guessing that they have some. They essentially show in the code how it's built, and then you can just replicate their environment. Yeah, you can only learn so much from looking at the code statically. That's true. But you can learn a lot, and I have learned a lot this way. I also have read books, and I've written a lot of code, and I've debugged code and debuggers and stuff. This was just, I find that this is helpful in a way that other stuff isn't. I think they all have their uses, and this is just something that I found to be really useful, especially for getting a sense of like what it's like to contribute to something, or what it would take to develop something, or just seeing different patterns in use. Okay, so where did our interpreter stuff go? So here we are back at the compiler, and I don't even remember if I answered my question or where we were. We were generating. Oh yeah, we were looking at these functions. Like emit code is one that takes no arguments, and so we'll just look at emit code. We're gonna, I guess, create some array of relocations. We'll compute code size again, passing in no arguments. We're gonna allocate some stuff, and then we've got this offset mapping and some EE vars I guess that's the execution engine variables. And if we have more than 0 IL vars, which I'm going to guess are, again, intermediate language variables, then we are going to create a new something, some debug info. Basically, we're creating debug information about all of the intermediate language variables. And then whatever this is, we've got these computing offsets, and here I guess is maybe the money method. Interp op is emit no op. Oh, this is just deciding whether it is a no op, and if it is, we are going to set the offset and then continue. Otherwise, we're going to call emit code ins, presumably instruction, passing in the IP, which is this p method code thing, the ins, which is, I guess, some instruction, the first instruction maybe, and the relocations. And so I don't know which one is which, but we know which is instruction to emit, I think, and then we know whatever this IP stuff is. What was it? P method code. I guess a code for the method. And we know like how to relocate it. And I guess that's enough to emit it. Let's see if we can find this method. Oh, you want to step through yeah, that's useful too. Although I found with a complicated enough program, unless you're debugging something in particular, there are too many branches to really get a sense of how the program works on the whole. Okay, so emit code instruction is going to take this IP thing, the interpreter inst, I guess, instruction in this relocations. Whatever this, okay, so IP is some pointer. We're going to do pointer arithmetic with it using the MP method code. And we're checking the offset. If the offset is not -1, then we're asserting the offset is bigger than 0. The native offset is bigger than 0. And we're going to convert offset somehow. And Microsoft prefixes their variables with type information, which I always thought was kind of useful, but now that I'm seeing it like this, I can't tell what variable is what, because they all look the same to me. Like the first 4 or 5 letters of every single variable is the same. IL to native map size, etc. So we're doing a bunch of assertions, and it looks like ultimately we're just looking things up into, we're setting maps of offsets. And that's all we're doing in this stanza. But then we're getting the opcode from the instruction, and the start, I pointed to the start IP, maybe the start of the IP. And we're going to increment the IP by the opcode. Why? That's a little bit... I don't. That seems a bit unusual. I don't know what IP is actually doing, but it seems unusual that you would want to increment it by the opcode. So like, opcode should be like, 1 is this method, 2 is that method. And so somehow the opcode has some sort of meaning that like the number 2 gets incremented by 2, and I don't know. I don't think what I'm saying is making sense to anybody, but the opcode should be basically a meaningless assignment of numbers to operations. So I'm not sure why we are incrementing these things. If it was incrementing by size of opcode, that would be expected. Maybe there's a reason in it, and it's obvious, and I'm just not seeing it. Yeah, good docs help a lot. Sometimes The docs are outdated. It writes to the pointer and then advances one step ahead. Is this? Oh. Yeah, you're right. I was just confused. I was reading this as plus equals opcode. So we're setting yes. Thank you, botyeeter. I've done that a few times where I get really confused by something. It turns out that I just misread the line of code. Okay. So yeah, I was reading this as we were incrementing by the opcode. So none of what I said is relevant or sensical. We're just incrementing it and then assigning the next the next thing in the IP array to the opcode. That makes total sense. Okay. So and then if the opcode is int-op switch, then we do some stuff. We're getting some labels. Incrementing by the number of labels, and so I think what IP is ultimately going to be is like the opcode is like which operation are you doing, and the IP is going to be like the instruction stream, or something along those lines. And then we're going to relocate with the offsets and all that stuff. So let's look at the IP type. Whoa, where is it? It came from here. Is it? I think it's a function argument. Oh, it's just an int32. Okay, well. It's the method, the MP method code. Let's see if we can find this string. So I'm guessing that we were setting the MP to the MP method code. Maybe that's just the start of this IP. But I'm going to think of IP as instruction pointer. That must be what it is. So it's like the I think it's really the instruction stream, but they're thinking of it as the thing it's pointing to is the instruction to be operated on, I guess executed. Let's see if we can find. Let's look for just instruction. The chances we'll find instruction pointer are nil. I guess let's look here. So here's an instruction enum. If define target xarg. Okay, so we have different instructions for different architectures. Is that obvious? I don't know. But we have instruction 1, for example, takes ID, NM, LDST, L destination maybe, FMT format, E1. And they look the same on ARM and ARM64. What about on AMD 64? Did I pass it? We've got xarg, which has ID, NM, UM, and MR. So we have RISC. No real instructions is used for load address. I don't know. Such a cursed way to declare enums. Yeah, this is really the code is very strange. So I don't know where. I don't see AMD 64. Is it because I'm in the wrong file? We have ARM64 and stuff. So if this is not, I don't know what target xarg is. Is that worth looking up? Blah, blah, blah. Maybe cross architecture? xarg symposium? I don't know. I don't know what xarg is, but at least we see some instructions for some of the architectures. Don't do that. Okay. So let's, I guess, I don't know. Let's explore the JIT directory, which I think I have open elsewhere. Okay, so in the JIT directory, we have compiler. I thought we looked at compiler maybe for the interpreter. Is this a different compiler? Compiler represents the method data we are currently JIT compiling. An instance of this class is created for every method we JIT. So botyeeter, you were correctly pointing out that the compiler is per method. This contains all the info needed for the method. So allocating a new instance per method makes it thread safe. Okay, I don't know if that's the point or just a fact. So I guess it's true that if you do it per method, then you can just send those many small compiler stuff to different cores and or different threads, and they don't have to know about some sort of global synchronized piece of information. We've got some forward declarations. Boss music. Okay. And declare global operator new overloads. I read that as overlords for a second. Use the compiler's arena allocator. New overloads that use. Okay, so I guess maybe the arena allocation is new or something along those lines. Or, all right. So is HFA. HFA info shared by LCL var disk and call arg ABI information. I don't know what HFA stands for. The following holds the local var info scope information. You've got a var name, which is an actual ASCII string. The var scope DSC. I don't know what that is, but barrier kind. We've got different kinds of barriers. And this thing, LCL SSA var disk. This class stores information associated with an LCL var SSA definition. Okay, I don't know what those words mean. Yeah. Oh, okay. So is that like a new feature of .NET that the JIT is multi-core? That would explain things. So this is looking like this. They're actually describing what something is. This is the basic block where the definition occurs. Definitions of uninitialized variables are considered to occur at the start of the first basic block. FG first BB. To do, cleanup. In the sense of uninitialized variables, the block is set to null pointer by blah, 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 blah. Okay, so we have some basic block, which is the first block. We've got some tree, the store node that generates the definition or null pointer for definitions of uninitialized variable. And we have an SSA number. I don't know what SSA is, and some stuff has phi use. Non-phi. I don't know what phi is being used for. But we've got blocks of code. Somewhere we should have something like the tree. Well, not like the parse tree, but the I'm forgetting all the things. Basically the code in the tree structure. This is an SSA def array, a resizable array of SSA definitions. Let's see if there's a SSA, we can find out what that is. Spike estimator class. SSA is a powerful framework for decomposing the time series. I don't think that's it. Some forecasting. Maybe it is. Is it? I'm pretty sure gentries are aggregates of basic blocks with the control flow in it. Yes. That was my guess. What are they called? Abstract syntax tree is what I was thinking of. Yeah. Static single assignment. Oh, yeah. Okay, hang on. Static single assignment form. Good call, botyeeter. Thank you. Often abbreviated SSA form, or simply SSA, is a type of intermediate representation. Okay, so now we're in the intermediate representation, where each variable is assigned exactly once. SSA, okay, so what does that mean? So, for example, if you have I equals 1, and you do some stuff, and you have I equals 2, I assume if we take this quite literally, we have I1 equals 1 and then I2 equals 2. So they're separate. We chop it up so that they're separate variables. Where each variable is assigned exactly once, SSA is used in most high-quality optimizing compilers for imperative languages, including LLVM, the GNU compiler collection, and many commercial compilers. And then we can efficiently convert a program to SSA form. Existing variables in the original IR, in the original intermediate representation, are split into versions. New variables typically indicated by the original name with a subscript, so that every definition gets its own version. Okay, exactly like I was saying in my hypothetical, but basically the variables are all now immutable, I think is the gist of it. In fact, do we get the word immutable here? No. Mute. Does it tell us the benefits? It's telling us here we go, benefits. The primary usefulness of SSA comes from how it simultaneously simplifies and improves the results of a variety of compiler optimizations by simplifying the properties of variables. For example, this line of code, y is 1, then y is 2, then x is y. Humans can see that the first assignment is not necessary. Being used in the third line comes from the second assignment. A program would have to perform reaching definition analysis to determine it. But here it's clear that y1 is useless. Okay. And then there are compiler optimizations. We've looked a little bit at compiler optimizations. We've definitely looked at GCC and LLVM. I don't think we looked too hard at the optimizations though. Phi might have a meaning in source code world. I don't know how to find that. Phi features. This might be hard to find. It's like looking for a variable. As arguments in regular, phi, and jump instructions. Here we go. SSA form and phi nodes. Is this an acronym or just a Greek letter? All LLVM instructions are represented in SSA form, static single assignment. We saw that. A consequence of single assignment are phi nodes. These are required when variable can be assigned a different value based on the path of control flow. Okay, so that makes sense. So in this example, a is 1 unless v is less than 10, in which case a is 2. It can't be determined statically. And then b is phi of a1 and a2. And phi selects a1 or a2 depending on where the control reached the phi node. Okay, so that's what phi is about. And has phi use, I'm guessing, is just checking whether the variable value is control flow dependent. And then so on and so forth. So this stuff is cool. This is finally something that is making sense now that we looked at some external documentation. But I'm going to just plow along because I think there's other stuff to see here. Phi and compilers. Yeah, that would have been a good search. Okay. So ABI should be application, binary interface, array stack, async. Async might be interesting. This should be bitvec, should be some bit vector. A block is maybe a block of code. Code gen is going to presumably generate some of the code. And we were just looking at compiler. I like this compiler phases. We have conventions, which is interesting. Data flow might be interesting. And disassembly, maybe. Emit. Okay, so we'll look at a few of these. Emit arm, emit jumps. I guess we'll look at emit arm. Why not? Emit pub. I don't know what pub is. RISC-V, Xarc. I think we can't necessarily look at all of them. Here's Gentry. And is there something like a like optimize? Optimize bools. Optimizer.cpp. Phase is maybe important. I'll open the phase.cpp. Range check. Rationalize. I'll open the header. And then what else? What's another way to say like optimize? I don't know, that should be good. Okay, so here's the ABI thing. I don't really know what I expect to see here. We've got some stuff like ABI passing segment. This is maybe information about how stuff is passed, whether it's passed on the register, in the register or on the stack. Start offset of the segment, blah, 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 blah. Get stack offset. So this is something about, I don't know what level this sits on. I don't know if this is adapting the like the VM to different architectures, or if this is the just configuring how internally they do passing. Passing segment iterator. The number of segments used to pass the value. For example, on sysv x64, structs can be passed in 2 registers, resulting in 2 register segments. On ARM64 and 32, HFAs can be passed in up to 4 registers, giving 4 register segments. Okay, so I guess this is like adapting. But what is HFA? Maybe I doubt it's an ARM specific thing, but maybe this will tell us something. Homogeneous or homogeneous floating point aggregate, a data type with 2 to 4 identical floating point members, either floats or doubles. Okay. I don't know when you would use that, but I guess you use that. So that's some sort of like special floating point that has like this 2 or more of the same. Rather, everything is the same, and there are 2 or 4 of them. There's a PGO feature, but I don't think it's in the JIT folder. What is PGO? Is that, are you saying that perhaps vectors? Yeah, I think they're like vectors with like constant vectors or something. Oh, profile guided optimization. Yeah, okay. I bet we can find that. Interp PGO table. It's in mono. Is that right? I don't really know what the mono layer is doing, honestly. Feature PGO. Oh, here's of course inc. What does inc include? Oh, okay. I think that maybe this is a is this like an external tool that you run on your CLI code in some benchmarky way? Utilize trace data for improving application performance. Okay. So I think that is using like empirical data, and that may not be in the runtime. That it may be part of mono. Mono is the Walmart version of course CLR. Very interesting. I think that's what people use to run it on Linux. Why use mono? It's a free and open source framework that aims to run software made for the .NET framework on Linux and other OSs. And it was acquired by Microsoft. And Microsoft transferred ownership of mono to Wine headquarters. So wait a minute. I had thought that there was mono stuff in here. Let's take this. Source mono. Is this still part of the, I don't know. We get no You get no README. So I don't know what they're doing with mono, but I also don't know how the PGO, where the PGO stuff lives. Let's take another look. Mono Mini browser scripts PGO check. Yeah, it's in the VM. Okay, we'll look at that in a little bit. Okay, so here's some asynchronous stuff. I'm guessing this is just some support for asynchronous programming. We've got some continuation layout, and I guess it's implemented by some continuation style. An async transformation, which is a friend class async liveness. It has a compiler, some JIT standard vector of live local info, and some core async info. And it's just got a bunch of info and some writers and some suspensions. And I guess you can transform. You give it a basic block and a gen tree call and some defs. I don't know what the defs are. Maybe kind of like things that need to be known by the block, and then some life stuff. I don't know, some sort of scope maybe, and then the remainder. And I don't know what the remainder is. Maybe it's the block that you call after you have done waiting or whatever. And this looks cool. This looks actually pretty understandable if you know how to use the async and you're willing to go through this code. But in the interest of just moving along, since I'm running low on time, I'm just going to move on to the next thing. Yeah, I think we found it, botyeeter. We'll get to it, I think, in a few minutes. Okay, here's a block. This is just the JIT/block. I'm going to guess this is like a block of code. We have a bit vector, some assert TP. I don't know what TP is. BB kinds. Byte. BBJ EH finally ret. Block ends with end finally. Okay, so I guess finally is like clean this thing up after you're done. I don't know what end filter is. There's a throw. Okay, so this is like control flowy stuff. Return always. So this is like a go-to, I guess. It always jumps to the target. Leave, et cetera, et cetera. But I guess these are concepts I'm assuming these are concepts in the intermediate format rather than in, say, like C# or F#. And these are just the names. I don't know why you can't have the names be part of the enum. I thought that was a thing you could do. I don't really remember. And a bunch of memory stuff. Memory kind iterator. Then we have a base class for forward iterators over the predecessor edge linked list. Base predator. Not predator, base pred iterator. That's something about, I guess, iterating to other blocks that preceded it, I guess. Maybe blocks that call it. I don't know which way the arrows go in this graph structure. Pred block list. Adapter class for forward iteration of the predecessor edge linked list yielding predecessor blocks using range based for, normally used via basic block pred blocks. Okay. I feel like I'm reading like a this is starting to feel pretty corporate, which is exactly what you want because it's a Microsoft based VM thing. But it's informationally it's a lot, but I think that this stuff reads as clearer, or maybe just I'm more familiar with the domain than the other stuff I was looking at. But it's something about blocks. I believe blocks of IR code and the graph structure. Flow edge, control flow edge. In compiler terminology, the control flow between two basic blocks is typically referred to as an edge. Most well known are the backward branches for loops, which are often called back edges. So I guess that makes sense if the loop goes back to the top. Struct flow edge is the type that represents our control flow edges. This type is a linked list of 0 or more edges. Every basic block has a field called BP preds of this type. Okay, so that's useful. If I had one suggestion for the Microsoft team, stuff like this, if it doesn't impact efficiency, I'd maybe put it more at the top or in its own file, just to make it a little bit easier to understand the code. If this nice block of text were at the top, I guess it makes sense to have the enums and stuff at the top too. But if there's like some of the stuff is really clearly described and some is not, and you kind of have to be willing to push through the stuff that's less clear to see what's more clear. Okay, so we're just gonna not look at this block anymore. Here's comp phases. I'm hoping this tells us about the compiler phases. Names of JIT phases in order. Assumes that the caller defines comp phase name macro in a useful way before including this file. Okay, so what are the phases? Enum name. Is this right? Am I reading this right? Is it enumeration style, all caps name? Whoa. No. This is just arguments. Okay, so we have an all caps name. The string name is an argument. Whether it has children, in other words, is it broken out into subphases? We should never do end phase on a phase that has children, only in leaf phases. And parent is -1 for leaf phases, otherwise it is the enum name of the parent phase. And measure IR is true for phases that generate a count of IR nodes. Okay, and these are the phases. All right, so pre-import, importation, indirect call transform, something about transforming an indirect call, maybe to a direct one or vice versa. Expand patch points. I guess this is maybe if you have some sort of patched stuff, like you have a method in a patch, essentially a diff, and you're going to expand the diff so that you have the literal text that was intended. Post import, profile instrumentation prep. So this is just like profiling stuff. Morph, whatever morphing is, we have init, inlining, and adding internal blocks. Add Swift error returns. I don't really know what that means. And allocation of objects, removing empty tries, and so on. Merge call finally chains. For, I guess, call finally, clone the finally. I don't know why we need to clone, but maybe because it's called multiple times. And then update and so on. And DFS, I'm assuming depth first search, blocks and remove dead code. I'm now no longer reading all of them. Morph by refs, morph promote struct, physical promotion. I don't know what that is, but perhaps like unboxing or something along those lines. Some GS cookie. I was going to read this as garbage collection cookie, but I don't know what GS is. Something. Garbage, perhaps. Maybe not garbage. Invert loops. Maybe that's for nested loops, like choosing the right direction. Optimize control flow to optimize player. Okay, so there's lots here. There are so many phases. This is maybe some of the most interesting stuff. I like the optimizing stuff. Yeah, they should put that in front of the docs. So they might put it in the docs, but it doesn't look like it's wrapped in any sort of delimiters for a tool to like extract and put in docs. So that may just be in the code, but I agree they should put that information in the docs, and whatever's in the docs should be consistent with what's in the code, which you can't really do if they're in two different places. So cloning is usually, says botyeeter, cloning is usually used in loops to have fast and cold path. Oh, okay, that makes sense. And the physical promotion is when you turn a struct into plain old data types on the stack. Got it. Thank you. Here's some data flow file. I don't know what it's doing. In fact, I think I'm going to skip it. I feel like I've seen where the flow I was interested in was to find disassembly. This, as I'm going to guess, is some sort of disassembly. We've got a JIT hash table with some size and some what? It maps a size to the size key funcs. Wait, what? Am I missing a piece of syntax here? Why is it taking a triple? I don't know what's being mapped to what. Some sort of JIT hash table. I was expecting it to be parameterized by two things. The key type and the value type, but we've got three. I don't know how they did that. I mean, I just don't know their convention. All right, dis init, dis done, dis open for late, dis asm. Disassemble a buffer. Called after code for a method is generated. So I'm guessing they're just taking the like assembled code and finding the corresponding intermediate representation or something along those lines. I'm just going to guess that's what it is and move along. Emit.h is some header for emitting stuff. Emit verbose, blah, 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 blah. Get string name to represent the GC type. We saw some GC type being used before. I guess it has some string that you get by switching because it's not part of the enum, which again, I'm not even sure you can do. Emit location has information about the code position. Some initialization. Set location is current location, blah, 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 blah. Some offsets. Emit location, blah, blah, blah. I want to see the code where they kind of decide which like opcode or whatever. Or I assume they have something that maybe takes an opcode and emits a piece of assembly or something along those lines. Here's some in-place holder group data. And this is, I thought this was a 5, but this is not something else. Let's see. Let's see if we can find opcode. I don't know. I'm kind of moving like pretty quickly through this stuff now, but let me see if I can find anything that I was hoping to find here. Emit a bunch of location stuff, offset valid, instruction group maybe. Emit LCR var adder, emit call params, and an emitter. Let's, I guess, look at the emitter. Did I pass it again? Okay, so its friends classes are emit location, compiler, and code gen. And what do we have here? Some protected stuff, like we're keeping a reference to the compiler, to the things we pass in. We've got some enum that encodes the op size, I guess the size of the opcodes. Well, there's only like 4 of them. Emit IG is in epilogue. And we're just like doing anding with some flag here. Emit address mode. This is some stuff about register number. And it depends, I guess, on the platform. And I don't know what the address mode is, but we're going to set register number to register number bits +1. And there's some debug info. I don't know. There's so much here. I can't, it's hard to tell what's really worth looking at, but I think I'm going to just not look at emit anymore. Here's the like ARM version of emit. Maybe this is what I wanted. If def en9 is none, instruction has 9 possible encoding types. Instruction has 2 possible encoding types. So whatever these are, there's somehow different ways of encoding an instruction. I don't know if that's something that's ARM related or something that's that can happen in general. Here's ID ops. So we have an op for local jump, label operand, direct method call, and special handling required. And I feel like we haven't really defined as much as I thought we would define here. Okay, well, that's doing some sort of magic. Emit pub, I don't know what pub is going to be. We have an unsigned emit code generator that has a compiler and some stuff. Did I see prologue? Prologue size. Oh, prologue is in the beginning and then epilogue is the end. Emit gen data. It's going to take a basic block label and some offsets and emit some stuff. Let's look at emit gen data. Or not. Okay, there we go. Here's Gentree. This is the node in a semantic tree graph. It represents an operation corresponding to the node and other information during code gen. Okay, so this is some tree that represents like control flow, I guess. So we have operator kinds, special operator, leaf, binary, unary. A leaf is like the bottom node. We have a cumulative operator. I don't know what that means. And we have like, does it produce a value? Does it not produce a value? Does it represent a store? I guess like a data storage of some type, like maybe an array or a map. And then we have different types for functions, like the user function, the JIT helper, and so on, and exceptions, and so on and so forth. And I'm just going to kind of go through here. Oh, here's optimizer. Offset block weights. So how big is this? Many thousands of lines. Let's see. Adjust block weights as follows. The lexical block ranges where the bottom reaches the top are scaled as a loop. There's a more general definition of a loop than natural loops, etc. So this is going to be long. I don't know if we're really going to get opscale much out of it. Opscale loop blocks. Scale the weight of the loop blocks from big BLK to end BLK. Calculate the loop weight. This is the amount of scale, the weight of each block in the loop. Our heuristic is that loops are weighted 8 times more than straight line code. Okay, so somehow this is like a cost, I assume, when they say weight, and they're going to presumably do some sort of cost minimization. There's some called a can reach. So there's some reachability analysis here. For curl block to be part of the loop that starts at big block, curl block must be reachable from big block. And since this is a loop, big block must likewise be reachable from curl block. Opt is loop inc tree. Okay, so this is compiler optimization stuff. And it's cool. And I'm going to guess that this would not be the cleanest repo to learn it from if you wanted to learn it. It's a different story if you wanted to see how .NET in particular optimizes things. But I'm going to plow along. This is the phases, I guess, implementation file. So I guess let's look at the check phase. This is just going to assert some stuff if we're in debug mode. Execute a phase and any before and after actions. Okay, so we have some pre-phase. I guess the phases have like maybe like a interface or structure with some like callback type things. And we have some pre-phase, and then we call do phase, it returns a status. Then we have post phase. So that's really clean. That's maybe maybe the first method that was implemented. And then pre-phase is just going to look at some debug stuff and presumably perform dumps and checks before a phase executes. So maybe pre-phase is the same for each phase. I don't know. Post phase. Status from the do phase call for this phase. And we've got like flow graphs stuff. So I think this is for like recording information and logging and stuff like that. Maybe pre-phase and post-phase are the same for everything. And it's essentially instrumentation. I have no idea what rationalize is doing. Rewrite node as a call. Rewrite sublostive compute stack. Rationalize visitor. Pre-order. So this is some graph walking stuff. I have no idea what this is doing. I'm going to guess that rationalize is something like an optimization, but for like sanity stuff, like sanity check here. Let's see if we can find the implementation of sanity check. Rationalize.cpp. Sanity checks that apply to all kinds of IR. So we're going to loop over the basic blocks in all the statement, and then we're going to call validate statement. Can we jump to validate statement? Maybe. That's a call. So validate statement, we'll call dbexec true, and then this compiler stuff, fgdebug check node leaks. Is dbexec some database thing? Rationalize or do phase. Run the rationalize over the method IR. I don't know. Maybe this is looking in some sort of database. Why? I'm not sure. We'll look up dbexec. If fulg expr. So is this just an if statement? Maybe it has nothing to do with databases. That seems like a weird, why call it dbexec? So this, what? So this is saying if true, sanity check. Is that what this is saying? This is crazy. Execute a SQL function if we were in R, but we're not in R. It does seem like it should be something about databases. Maybe that was just a re-implementation of, I don't know, man. dbexec. Uncomment to print internal implementation details. So, okay. What if we try to find dbexec? Just this. Although there's a second definition below. So where's that? Oh, debug, maybe? Yeah. So I think somewhere up here it says to define these only if debug is on. So I guess this is like debug exec, and it's something that executes only if you're debugging. And so the sanity checking is for if you're in debug mode, I guess. That's fine. All right, so here's PGO. The PGO manager handles in-process and out-of-band profile data for JITted code. So get PGO instruction results. We're reading some type of data, and we have methods and core JIT info. And we can create a PGO manager. And what are we doing with it? Code and method hash. This is maybe just hashing the method for combine two values in a hash. I think this is just creating a like a hash so that there's a single place to a thing that encodes a single name essentially that encodes all the information. And the header, I guess, for PGO stuff has the method, or like a pointer to the method, or rather maybe a description. The code hash, the method hash, the IL size, maybe intermediate language size, and the count offset. And what else? get PGO instrumentation results instance. Enumerate PGO headers. So this is still like, I feel like we're like reading data, preparing to store data, load allocator PGO manager. But where do we actually act on any of this information? Let's go back to all symbols. Verify address. We can create the manager, code and method hash. This is all stuff we've seen before. Header, load allocator PGO manager. I feel like, so where's the manager defined? Oh, it's defined here. Initialize and shut down. Let's see if the implementation has anything more more telling. This is a data structure for holding PGO data. Need to be walkable at process shutdown without taking meaningful locks. Okay, so this is the data. We saw that being defined. Verify address to do insert and assert to check that an address is a valid PGO address. Schema writer function. So we've got this schema writer function, whatever it is, it's got some byte data, some type handles encountered, some array of type handles and some methods encountered, and it's going to write some stuff. And maybe this is just about reading and writing the data, and I don't know how it's consumed. It doesn't seem like. Maybe we can look at a couple of other things in the VM. There's really too much here, I guess, and I have to go soon. So we get an optimizer here. Optimize. I think we're back at the top. Okay. So, I don't know. But the VM, I think we decided it's going to do what? It's going to interface between the, it's basically going to use the JIT compiler to decide what to compile. I guess it'll also do the interpretation. I don't know. I'm trying to look at these and I don't even see what a good, like, fun entry point to end on would be. So we do see some garbage collection. IL marshallers. So this should be for marshalling the intermediate language, I assume. IL stub marshal home. IL local, IL argument, IL byte ref local. Home index local destination. Emit unaligned prefix if needed. Yeah. So this is something about marshalling and unmarshalling, like I guess like serializing stuff, but who knows? We can look at the GC. Okay. Yeah, sure. We'll look at the GC and that'll be the last thing I guess that we look at. So I don't know if GC is its own folder. Is it in VM? Here we go, GC. Env, I don't know what env would be. GC, so this, I'm going to guess it's, I assume everyone just uses mark and sweep. GC scan. GC severance. I'll just open a few of these. Software write watch. Okay, so here's the GC header. GC stress does not currently work with standalone GC. Okay, FGM. I feel like we've seen FGM a few times. I don't really know what it means. Maybe failure get memory. Something. Failure get memory. GC reason. These values should be in sync with the GC reasons in event trace. Okay. So maybe these are reasons it was collected, like it's empty. We were low on memory, or maybe reasons the GC is running, induced out of maybe space, out of something. And S and L. Short, long. And then we have GC stress, etc. Okay, so those look like reasons. I'm wise to you now, Microsoft. I'm going to assume that the actual code is like halfway down. Fragmentation. That's possible. So we have is GC in progress, IGC heap internal. GC heap. So this should be the heap, the DAC heap walker. I don't know what DAC is. IGC heap internal. Let's go to GC heap. Maybe. That's not what I want. So we have a GC heap and a GC underscore heap. I don't know what WKS is. Let's see. And then we have BGC. We do have some references to marking and sweeping. Let's try to look at object. Oh, these are all like forward declarations. Is there any? Help. Okay, IGC heap internal. I guess GC is garbage collection. I is maybe interface. So maybe this is the internal interface for garbage collection. We can get the number of heaps and get the max generation. That's like, I assume like how old are you allowed to get, and valid segment size. I don't know what a segment is in this context. Go through and touch each page straddled by a memory block. Touch pages. And then some write barrier check, which will update the GC shadow. I don't know what shadow is. And then here we have the single GC heap instance shared with the VM. So the VM has some garbage collector heap instance, and this is a reference to it. I don't know if that means that that this collects the VM's garbage as well as your application's garbage. I don't know. And then here's a reference to the manager, and this is just a Boolean that tells you whether garbage collection is in progress. And if we take, let's see where this this variable is set. That will maybe point us to the right code. If we can find out where it's set, it should be set by whatever is actually doing the garbage collecting. Oh, wait, this is just a reference to the heap. Where's the progress? Oh, sorry. This is just saying it's not it's not a null pointer, and this thing is but we've got some progress helper, and we're passing in something. I'm not sure. Let's check out some of these other files. Here's the CPP file for implementation. GC rand, maybe random. A segment is a continuous virtual address that sits in a linked list in the heap. Okay. Thank you. DAC is for debugging. And you should check the GC heap type, which uses the GC underscore heap. Okay. I'll check that type. Well, I'll look at the CPP file. It might be more easy for me to understand. Okay, so we have some class GC rand, which is just a simple random number generator for the garbage collection. I guess it doesn't have to be secure. So they're just taking some constant and anding it with some other constant. And where is it? What other symbols do we have? We have some high precision timestamp. Add to history per heap, add to history. Shut down. I don't know what this join stuff is. Maybe like like joining garbage collection from threads. Exclusive sync. Align owned. How about mark? No. Of course not. GC heap, mark, stack, array, 0. Yeah. So where's this GC heap from? Did I spell that right? Heapy. No. Oh, of course. It's in GC imple. Or no, it's not even in GC imple. GC priv. Let's try Emacs. What folder are we in? Source core. Okay, I was missing the source. Okay, so let's just pick one of these random victims. It doesn't seem to be. So we have this declaration here. Oh, here we go. It is in GC priv. Okay, class definition of the internal class. So what do we have? We have the friend class is big uppercase GC heap. I'm wondering if that's the public version and the lowercase version is private, which I guess is what the convention of Golang. We've got some allocation context, a prof scan roots helper, maybe profiling scan, something about roots. I don't know what exactly. Maybe we have a forest and it's figuring out where the roots are. We have a profile walk heap worker. It's going to walk the heap, I assume. And it's maybe going to, or it might profile the heap walker. I don't know. This is something about aligning allocation, passing in some allocation context, the GC heap itself, and the size and some flags. T join, I'm going to guess is thread join. GC mechanisms is just, sorry, these are just friend classes. Okay, this is for like testing and stuff, but I guess it's somewhat useful that these are all, I guess, like tightly intertwined with the GC heap thingamajig. And if we have multiple heaps, we might have this thing. I guess it's like an array of some cardinality. And then the public methods, table mapping region, number to generation. There are actually two. Okay, so we've got some table mapping region number to generation. So I guess we've somehow numbered the memory regions and they have been assigned a generation for the generational garbage collector. There are actually two generation numbers per entry. The region's current generation and the region's planned generation. And there are flags. So you would think that maybe the planned generation is the increment of the current generation, but I guess the flags may make that different. And whether the region is sweep in plan, I guess that means is it planned to be swept in the next run or something? And whether the region is demoted. The lowest 2 bits are the current generation number. Okay. I don't know what RI is. That might be just type information. So generation 0, 1, 2 in a mask. And then we have 4 bits available for flags, of which 2 are used. Okay, so the SIP and demoted. So demoted, I assume, is you go to the previous generation. And SIP, I don't know, something in place. Hey dude, hey alpha. And the top 2 bits are planned generation number. And the I guess it's parameterized, at least this, if this flag is set or something, by how much to shift the value right to obtain the planned generation. And then we have planned generation 1, 2, and mask. Okay, and then we have a bunch of private methods. Some stuff with printing. This is entirely unreadable. Like synchronization stats, etc. Whether we have multiple heaps, this code will execute. Verify SOH segment list. I don't know what SOH is, but we have some verification stuff for regions. Fire per heap hist event. This is maybe for firing some event that occurs every time there's the garbage collector looks at a heap or something. Current GC data per heap number. SOE, small object heap. Oh, okay, thank you. Well, 0, 1, 2 work as virtual limits. They work by exchanging segments regions depending on the budgets. What do you mean by depending on the budgets? So, you mean like the generations can be different sizes? Or something along those lines? Get plan generation number. So we have some like getters for. So if this is small object heap, this is something. U object heap unassigned. Each generation has a memory budget. Okay, got it. That makes sense. We've got a bunch of methods if we're using regions, which we may not be. We've got stuff to check, like if there's enough memory in the regions. We'll just assume that we're not, I guess, using regions, because that skips a lot of stuff. Accumulate committed bytes. Accumulate the committed bytes for both the region and the mark array for this list of regions. And this is there even if we don't use regions, I guess. Destroy GC heap, make GC heap. So there's a bunch of stuff. A lot of this looks like it's for like logging and checking performance, which makes sense. But I would like to see like, how about some marking and some sweeping? Walk, relocate args. This something about walk survivors that is looking more like GC stuff I'm familiar with. We have walk heap, which is a method, and it runs per heap, I guess, is what this, I'm assuming is what this means. And we've got a walk function. So you're going to, I guess, execute as you walk, we're going to visit each thing and execute a function on it, passing in some context and what generation number is. And we've got this Boolean. And how does it know? It says per heap. Maybe that's encoded in the context in the generation number. And then we have walk heap per heap, which is a per heap method as opposed to a per heap isolated method. And I don't know how they differ. We have walk survivors, which is going to take a record serve, like a survey function, a context, and the walk survivor type. Okay, so let's look at a few of those. Just out of curiosity. I'm really curious about the survivors things. But let's go. Is that going to work? Look at walk survivors there, and then we'll look at this walk heap per whatever. So walk survivors is going to take this record serve function in a context and some walk serve type. Oh, serve, not survey, is survivor. Walk survivor function. Okay. And if the type is walk for GC, then we call walk survivors relocation on the context in the function. Otherwise, if the type is walk for BGC, I don't know what BGC is, we're going to call walk survivors for BGC. Otherwise, we're going to call unknown type. So let's look at this non-BGC version. Walk survivors relocation. Now walk the portion of memory that is actually being relocated. So we're going to call walk relocation on the profiling context with the function. And if we're using maybe large object heap, we, I guess, compaction. So we're going to, periodically compact stuff. Then we call this version of the function. And what is walk relocation doing? Okay, so walk relocation is going to take a profiling context in this function. And we're going to get the condemned generation, which is, I guess, the number of the generation that is we're viewing as condemned. Presumably condemned means we're going to release these the memory that they're occupying. We have a stop generation index. And I don't know what this resetting of queued stuff is, but we're going to walk from the condemned generation number is the bottom, and we're going to walk up to the top, and we're going to get the generation of I, and set it to condemned generation. It seems like we're going to do that for everything. And then we're going to have this heap segment RW, maybe read write. That's going to give us a current heap segment, walk relocation SIP. I don't know what that is. And if we don't have a current heap segment, we'll continue. Otherwise, we'll get the small object heap start object. That'll be the start address. And whatever a brick is. I don't know what a lot of these terms mean. But I guess that maybe the small object heap is like the start of the whole generation or something along those lines. And whatever the brick is, we're going to get the end brick. Maybe that's just the end of it. And while the current brick is bigger than the end brick, then we're going to call a heap segment next. And we've got some brick table. Yeah, I don't know. Thanks, man. I'm missing this conversation. I don't know. I don't know what Valorant is. Is that I assume that's a game. Not really condemning is linked to the ones we want to collect. I think the freeing of memory is done in a separate way. Okay. Let me I think I misspelled condemn there. I misspelled it as much as possible. Condemn. No, I didn't. Heap. Okay, so let's just ask Gemini in garbage collection. And generation of the condemned refers to the specific generation of objects that have been selected for garbage collection cycle. Yeah. When the garbage collector decides to run, it needs to choose which part of the heap to process. It decides to collect. If it decides to collect the young generation, then the young generation is the condemned generation. All objects within it are candidates for reclamation if they are no longer reachable. Sometimes it might decide to collect an older generation. In these cases, the older generation or all generations become the condemned generation. Why condemn? Are being evaluated. The garbage collector will trace live objects starting from a set of roots, for example, local variables on the stack or global variables. Any object in the condemned generation that is not found to be reachable is considered garbage and its memory can be reclaimed. Essentially, the condemned generation is the target of the current generation. Okay. So so is that consistent with what you were saying? Oh, you're saying that maybe what you're saying is that we're just that maybe this is the mark phase as opposed to the actual freeing, which might be part of the sweep phase or something along those lines. Yeah, I think that they're not actually freed here. I think we're just deciding. We're just walking and deciding whether they are reachable. But I'll be honest, I find this code to be very, what's the word? It's not so clear. There's lots of if-defs in the middle. It's not laid out in a way that makes it clear what's important and what's not important. So the walk relocation, I didn't really see. There was some call somewhere to relocate, but I didn't really follow through to that. But do we have like a sweep? While we are in LOH sweep, we can't modify the segment list. So somewhere, what time is it? Okay. Background ephemeral. How about background sweep? Is that possibly the real sweep? Concurrent print delta. That's some comment. So concurrent print delta, SW, I guess, indicating sweep. And then we have dprint too. Oh, no, this continues. I thought this was the end here. Okay, so for sweep, we're going to iterate over from 0 through all of the generations and get the generation of each, I guess, object or whatever one unit is here, maybe a region. If we're in the max generation, then we're going to call this rebuild max gen FLP thing. That's going to give us a clear FLP. I don't know what that is. And we're going to print some stuff out. Generation 2. We're going to call it generation 2, even though the max generation is not necessarily 2. Has FL. Maybe float? No. Something. Has FL, FO, and clear gen 2 FL. Oh. Free list space? Free object space. Thank you, names of these functions. Okay, so this is we've got some free list and some free objects, and it's just printing out the stats of what those things are. Yeah, thanks, botyeeter. Yeah, that's exactly what we're doing. Okay. So, and then we've got this, if we're supposed to clear the FLP, which I'm guessing must be the free list, and then whatever P is, maybe pointer. If we're supposed to, whatever clear FLP is, and we're in the max generation, we're going to debug stuff. And then we're going to call generation allocator. Passing in gen to reset, and we're clearing. Okay, so this is clearing all the stuff in the whole generation. Is that right? And we're calling the free list space clearing the whole generation, and so on. We refer to the free space on the segment that we didn't touch yet. And the free, yes, I think that's right. When it frees an object, it puts it on an exponential bucketed list. Okay, thanks for stopping by, Alpha. Okay, so so this is free. I think what you're saying is right and consistent with what I remembered, but I didn't really have in my mind right now. Which is that we have a list of the free space where stuff can go. An exponential bucketed list. I'm not sure how that works, but I'll look it up in a second. But this here, whatever the generation allocator is, it seems like we're clearing a lot of stuff. And this is just saying that we don't have any free space or free list space or free object space left. We're setting them to 0. But if we're not doing this clear FLP thing, then we are setting these things to 0, I guess, still, and calling generation sweep allocated, which we didn't do up here. Sweep allocated. So this seems like we're just destroying everything. And this is maybe, I don't know. I guess we're looking in only the allocated space and sweeping there. And then we're going to reset some allocation pointers, allocation limit, allocation segment. We can jump into some of these. I guess let's look at sweep allocated rather. Whatever inst is, we're just calling sweep allocated on whatever inst is. And inst seems to be platform dependent. We've looked at game engines before. Bingo bongo. So we've looked at, in no particular order, MAME, the arcade engine. We've looked at a few of them. Godot. And some others. But off the top of my head, I forget them. And so you have X buckets. The first bucket is 2. Okay, so they're exponentially increasing in size, like doubling in size. Okay, that makes sense. I do have to go. It's 12:30, and I feel like botyeeter, you understand this code a lot better than I do. But that's something about the garbage collector. I feel like there was one more thing I wanted to see before I left in the garbage collector, but I don't remember what it was. I mean, we can look at, I want to see, I guess. Yeah, let's look at the generation allocator. I guess it's just looking at the whatever's in inst. This is the free list for this generation maintained across GCs. When we condemn a generation, the free list is rebuilt for that generation. For the non-condemned generations, this is maintained. For example, when we are doing a Gen 1 GC, we will be using Gen 2's free list. Okay. Is that going the direction I thought it was? Are they being promoted from Gen 2 to Gen 1? At any rate, when they are doing a Gen 1 GC, they'll use Gen 2's free list. And then but if you're at the, I guess, yeah. So if you're at the end, there's no, I guess, list to use. And so when they can, as long as it's not condemned, I guess. If it is condemned, they rebuild it for the new generation, I guess. If we rearrange regions between heaps, we'll need to make sure that the items on the free list are threaded into the generations for the new heap. If the region if the region that contains these items are moved to that heap. Okay, so if you move a region and it contains objects, you need to make sure that the stuff on the free list, I guess, for those objects is moved with the memory or with the region. For example, if we move a region R0 in Gen 2 from heap number 3 to heap number 5, all the items in R0 will need to be taken off the heap number 3's Gen 2 FL and threaded into heap number 5's Gen 2 FL. If we merge multiple heaps into one, we could simply thread all heaps free lists together, etc. Okay, that was a useful comment, but it doesn't tell me what the implementation is. And I think that's about where I gotta stop. So that was cool. That's a huge project. We saw a smattering of it. The code it kind of took me a while to figure out the style of code. I feel like once I did, it was a little bit easier to get around, but at least with stuff like the garbage collector, there's kind of a lot of noise, and the first time looking at it, it's unclear what the signal is. botyeeter, you helped an immense amount. I really appreciate because you had context, and it seems like you are more familiar with the memory management as well as being more familiar with the .NET space. So I really appreciate that. And thanks for hanging out. Before I go, I want to make sure I read these comments. Formula's done. Okay. So when they want to put free objects on a list, they have to use Gen 2 because the objects will already be promoted. Oh, okay. That makes sense. Fun and headache inducing. Well, thank you so much for hanging out. I will see you all next week on Ants Are Everywhere.